seem to be getting any of your emails. So like the
No.
test, I didn't get that.
Okay, let me check something real quick. Oops, that's the wrong one. What's your last name?
Breaux, Breaux.
Oh, yeah. Somehow you've been subtracted from the list. I'll add both your emails.
Okay.
Hopefully it'll add the Gmail. It doesn't always add Gmail.
No problem. I answered to both. Yeah, because when you said about tests, I was like, wait, we got a test? What? But I will try and get that done tonight.
I'll tell you what. I'll send it to you right now,
Okay.
and you can go ahead and. Yeah, it's not adding your Gmail. Sorry. It added your other one though.
Okay.
I'll send it to you right now, and I'll let you take it instead of coming to class today.
Okay.
Sound good?
Yeah.
Because we're going to be going over it.
Oh, okay. No problem. Yeah, it sucks being in quarantine.
Oh, gosh.
It's not fun. But no, I would go on the YouTube channel every day, and nothing would be there, so I kind of would just
Interesting.
watch every time it would upload after.
How do you spell that again? B
Reaux.
Reaux. And attach.
If the Soul Ross one's easier, just go ahead and do that one. It doesn't.
Yeah, I'm sending you the
Doesn't
Sol
bother
Ross
me.
one.
Okay.
Just gotta actually get the exam on here. Alright, I just sent it to you.
Okay. So just go and take that and
Mhm.
see you Wednesday?
Yep.
Okay, thank you.
Have a good day. Okay, let's go ahead and get started. So, by the way, people on the stream, something's up with the internet today at Sol Ross, and so it might cut in and out. But if it does cut out, it'll come right back. It has been all day. All right. So last time we took our exam, and I sent out the grades, right? Can't remember now. I know I have the grades. I'll send them out again. But what I want to do today is I want to go over this and see what the real answers should be, because there was some confusion on a lot of these. So, number one, determine the following radical expression is a real number. If it is, you are to evaluate the expression. Okay. So first of all, the only thing that would make this a non-real number is if we had a negative underneath the square root, which we do have a negative, but it's outside that square root, so this is a perfectly real number. So that's the first part of this one. And then, since it's a real number, we need to simplify this. So we have negative square root of 64. We need to break this up. Well, what is 64? What times what? 8. Yeah, 8 and 8. Well, that's easy. We just need a pair, right? Well, there's our pair. So this is negative on the outside, and then we know the square root of 64 is 8. So there's the answer. Uh-oh. Looks like, yep, I gotta reset some real quick. And that should be broadcasting correctly now. Okay. Sorry about that. Technical problem for the stream. Okay, next one. Simplify the following radical expression. And so it gives us the square root of 25x squared. Okay. Well, first of all, we know what the square root of 25 is. It's 5. And then x squared. So remember what we're doing when we have a number with a power on it and it's underneath a root like this is we take the power and divide it by the type of root. Well, the type of root here, it's not expressly said, but it's square root, so it's a 2 there. So 2 divided by 2 is 1, so we have x to the first. So our total answer here is 5x. Any questions? None? Makes sense? Good. All right, this one's a little hard to see because of the font size, but it's the square root of x squared over 49 x to the 6th z to the 18th. So once again, what we're doing here is we're going to be taking the square root of these powers. Now, before we do that, we really ought to make sure this is as simple as we can make it, and actually there is something we can do underneath this root before we take that root. We have x squared up on top, and we have x to the 6th on bottom. So we have a power being divided by another power. So what do we do there? We subtract. And the larger number is where that power is going to end up. So it's going to end up on bottom since 6 is the larger power. So 6 minus 2 is going to give us 4. So we end up with x to the 4th on bottom. So let me rewrite this real quick. We eliminated everything on top, so there's just 1 up there. Then on the bottom we have 49, x to the 4th, z to the 18th. So now we can go ahead and take the square root of all these. So the square root of 1 is 1. Square root of 49 is 7. X to the 4th, or remember that what we're doing here is we're going to take this power and divide it by the type of root, which is a 2. So 4 divided by 2 is x to the 2nd. And then z to the 18th, again, 18 divided by 2 is going to be z to the 9th. Any questions? All right. So far, these have all been numbers that are perfect roots. Now we come to one that is not a perfect root. So simplify the following radical expression. We have square root of 45. Again, this does not take a perfect root. If we were to put this into a calculator, we'd get some kind of decimal. And the decimal is not what I wanted. And I did have, not many, but a few people give me a decimal for this problem. What I wanted you to do is, again, simplify. So we need to break up 45 as its factors. So what times what is 45? 9 and 5. And 9 is what? 3 and 3. So to simplify this, we find matching pairs. So I got a matching pair there. That means a 3 can come out. And then we have the number left over is just still in that root. So the answer I'm looking for here is 3 square roots of 5. Any questions? None? Okay. That was really the one that was probably the worst problem was people putting decimals here. Again, that wasn't many people, but I did see it. All right, next. Simplify the following radical expression by rationalizing the denominator. Okay, so again, kind of hard to see, but what we have here is the square root of 21 over the square root of 6. And this is not rational because square root of 6 gives us an irrational number, a decimal. We want to rationalize that denominator. Okay. Now, can we reduce this fraction before we start rationalizing? So do 21 and 6 have something they can both be divided by? 3, yes. So if we divide both of these by 3, we get the square root of 7 over the square root of 2. Okay, so now we can start rationalizing. Of course, if we want to get rid of that root, we multiply it by itself. We have to do the same thing to the top. Okay, so square root of 7 times square root of 2 gives us square root of what? 14. And then square root of 2 times square root of 2 gives us what on bottom here? Square root of 4, which is what? 2. Good. So the answer we're looking for here is the square root of 14 over 2. Any questions? Nope. Makes sense? Good. Next, convert the following expression to a radical notation. All right, so right now it's in exponential form, which means it's written with an exponent. Remember that these can be rewritten as a root. So what we have is y to the 6 over 5. So one of these numbers becomes the type of root, and then the other number becomes what y is being raised to. So which one is the type of root, 6 or 5? The top or bottom number? It's actually 5. Remember that what we're doing is we're dividing the power by the root, right? So if we do that here, the power divided by the root, the power would be the one on top. The root, the thing we're dividing by, is the one on the bottom. And that's how you convert back into exponential form. Any questions? Now this can be simplified a little bit, but all I was asking for is for you to convert to the, the radical form. Oops. Oh my goodness. Go back, there. All right, so again, all I wanted you to do was go to the radical form. You didn't have to simplify it after that. If you did, cool. Any questions? All right. So moving away from radicals, for the moment at least, we have polynomials. So first of all, classify the following expression as either a polynomial or non-polynomial. Okay. So we have add and subtract, which is a good indication of this being a polynomial. The one other thing that we need to look for is any kind of rational exponents. So exponents that are fractions, we don't see any of those here, and negative exponents. Because remember, if we have a negative exponent, what does that mean? It's going to flip to the bottom, right? Yeah. So then we'd have all of this thing over something, and indeed, we have a negative exponent here. So this would come out to be negative 8y to the 7th. Let's see, 6x to the 7th negative y to the 13th all over y to the 6th. So that prevents it from being a polynomial because now it's this whole big thing tied up in a fraction. It's a non-polynomial. Any questions? Okay. Next, consider the following polynomial. Express the polynomial in descending order, identify the degree, and identify the leading coefficient. So let's first of all put this thing in order. We need to put it in order of the powers. So the first thing is negative 4y to the 6th. Then the next lowest power is y to the 2nd. And then the next lowest is 6, because that's technically y to the 0 power. Okay, so that's the ordered version. Now we need to find the degree. Remember that the degree is the highest power in the polynomial, which in this case is 6. And the leading coefficient is the number out in front of that number that has the degree on it. So in this case, negative 4. There we go. Any questions? Okay, I'm pretty sure most everybody got this one right, which was good to see. Okay. All right, next one. Multiply the following polynomials as indicated. I think I only had like 1 or 2 people mess this one up and they added them instead of multiplying them. So what we need to do is we need to distribute these numbers into here. So we'll start with 3y, distribute it. So 3y times y is 3y squared. Then 3y times 5x is 15xy. Okay, so we've gotten that one done. Now we need to distribute negative 6x. So negative 6x times y is negative 6xy. And negative 6x times 5x is negative 30x squared. But we're not done yet. We need to make sure that this thing is simplified. So we have common terms, or like terms here, 15xy and negative 6xy. So if we go ahead and do the subtraction there, our final answer is 3y squared plus 9xy minus 30x squared. Any questions? Yes, ma'am. How come that's last? That's a good question. So it does not actually matter what order they're in, first of all. But when we're dealing with multiple variables in a polynomial, we basically choose which one goes first. So like we usually put it in order of the descending degree, right? But both of these have the same degree. And so we basically get to choose which one we want to go first. Now, since we multiplied this and this is the way it came out, that's just the way we write it. You know, if this had been like x in front and y back here, then it would have come out the other way and we'd write it that way. So it doesn't really matter, but when we're dealing with multiple variables in a polynomial, we want them to oppose so that this one descends to here and this one ascends to here. Any other questions? All right. Next one. I was very happy with this one. This one is always one that I get a lot of wrong answers on. And this is one of the first times I can say pretty much everybody got this one correct perfectly. So it says find the product of the binomial factors using the appropriate special product, or whatever. We're just squaring this thing, which everybody, or at least pretty much everybody, wrote it out, and then multiplied, which is exactly what I wanted to see. So very good. All right, so let's go ahead and multiply this. So x times x is x squared. X times 1 is 1x, or just plain old x. 1 times x, again, is plain old x. 1 times 1 is 1. So if we go ahead and simplify this, combine like terms, we have x squared plus 2x plus 1. And there's our answer. Any questions? All right. Next. Factor the following trinomial. If it cannot be factored, indicate not factorable. I didn't put anything like that in here. This one can be factored. Okay, so again, it's a trinomial. So we need to use the AC method to try and factor this thing. Which, hey, pretty much everybody got this one right too. I was happy to see that. Again, this is one of those ones that gives at least my past students a lot of trouble, but y'all seem to tackle it extremely well. So our A is 1, our C is negative 35, so 1 times negative 35 is negative 35. And we want factor pairs that will give us 2 when we add them, positive 2 when we add them. So 1 and 35, let's see, what else? 5 and 7, and hey, I think that'll work. So if we make this a negative 5 and a positive 7, they will multiply to get negative 35, but combine to get positive 2. So we can rewrite it, and I'm going to just skip that part and go straight to the box method. So our first term goes in the first box, last term goes in the last box. Then negative 5, I guess I'll put here. Just make sure that the negative goes there. And 7 goes there. Okay, so now we need to factor our rows and columns. This row, they both have y in common. They can both be divided by y. This row, they can both be divided by 7. This column, they can both be divided by y. And this column, they can both be divided by 5. So our two factors are y minus 5 and y plus 7. Any questions? Okay, now that we've gotten past this exam, I want to show y'all something. There's a shortcut we can actually take with this. So, notice that our two numbers that we got for our factor pair are the same numbers that are in our factors, right? Negative 5 and negative 5, positive 7 and positive 7. If your leading coefficient is 1, once you get these factor pairs, you can fill them in to your factors. So find the numbers that will give you the number in the middle and just fill it in. So what's our variable? Y. Put the minus 5 next to the y. Again, what's our variable? Y. Put the plus 7 next to the y. Again, that only works if you have a leading coefficient of positive 1. If it's anything else, this will not work. But I want to tell you that because in the future we're going to see some pretty big problems that we got to do, and they have a lot of these things we got to factor. And if we notice that we can just skip to that, it's going to save us a lot of time. Any questions? All right. Next one, 12. Use the special factoring methods to factor the following binomial. If it cannot be factored, indicate not factorable. Now this one's factorable, but it's a binomial. So it's going to be factored either one or two ways. The first way would be with a GCF. So can both of these values be divided by something? No, they don't have anything in common. Nothing that I can divide both of them by. Okay, so what about a difference of squares? Okay, well, we do have a difference, and this is x squared, so that's a square of x. This is 49, so that's a square of 7. So this is a difference of squares, which means we can factor it in two parts. So the first part gets a plus, the second part gets a minus, and we just fill in the blanks. So the square root of x squared is x. The square root of 49 is 7. That's it. Any questions? Okay. All right. Now we're getting into non-real numbers. So this one says evaluate the following square root expression. So this one, we have a negative underneath that square root, which means this is a non-real number. So the first thing we need to do to it, if we want to simplify or evaluate it, is to split that negative 1 off of the 4. Now, we know what the square root of 4 is, don't we? What is it? 2. All right, and then what happens with the negative 1? What does it become? I. Yes, the square root of negative 1 we write as I. Any questions? Okay. Next one, simplify the following expression. I kind of had the opposite problem with this one that I had with that previous one. I had, I think, 1 or 2 people multiply these together instead of add. So always make sure you're reading carefully what the instructions are telling you to do. Okay, but again, it's just add. So we need to combine any like terms we might have between these two values. Well, I don't see another I squared to combine 14i with, so it's just going to come down. All right, I've got negative 6i and positive 5i. Those can combine. They're like terms. So let's see. That'll be, minus 1i. And then 8 doesn't have anything it combines with, so plus 8. Now if you wrote this, I counted it correct. This is perfectly fine because all it says is simplify the following expression. And most people stopped here. However, there is something else that we can do to simplify it further. I squared is a value that we know. I squared is negative 1. So negative 1 times positive 14 gives us negative 14. Combine that with the now like term 8. Okay? So what is negative 14 plus 8? 6, negative 6. So really, the most simple form of this would be negative 6 plus, negative 6 minus I. It doesn't really matter which way you write it, but I want to make sure I have it appropriate. Okay. Any questions? All right. Next one, simplify the following expression. So here we do need to multiply, and actually we're multiplying conjugates, not just that, but complex conjugates. So this should come out to be a single real number. Okay, let's see what we get. 3 times 3 is 9. 3 times 8i is going to be 24i. negative 8i times 3 is negative 24i. And then negative 8i times positive 8i is negative 64i squared. Okay? Now the I squared, simplifying it here, is absolutely necessary. Okay? So these two, they're opposites, they cancel each other out. Negative 64 times I squared, remember that I squared is negative 1, so that makes this positive 64. Okay? So now what we have is 9 plus 64. And what does that come out to be? Is 70 what? 73, yeah. Good. Any questions? All right, one last one. So we have simplify the following expression, and it says I to the 157th power. Okay, so first we need to divide this power by 4, because we know that the powers of I have 4 steps in their pattern. So again, we divide this power by 4. So 157 divided by 4 is 39.25. And 0.25 corresponds to the first step in our pattern, which is I to the first. So this just comes out to be I. Any questions? All right, well, that was the exam. How do we feel we did? Okay, well, looking at our grades on this exam, we did more than all right. It was actually fabulously well.
Did all of us pass?
Let me take a look. I do have the grades here. Folder. It's taking a minute to load. Come on. Oh my goodness, it's taking forever to load. There we go. Let's see. Yes. All the grades that I have in here are passing grades. Yeah. You can come up here one by one and I can tell you what you got, but let me end the stream first so the stream can't see your grade, all right? So that'll do it for today, guys on the stream, and I will see y'all later.